Faraday's laws of electromagnetic induction. Electromagnetic induction is a concept proposed by Michael Faraday in 1831. It provides the basis for different electrical apparatus such as motors, generators, transformers, etc. And his proposition can be specified in two laws. First, Faraday's first law of electromagnetic induction and second law of electromagnetic induction. Let's go through these laws. EMI, electromagnetic induction. It provides the basic relationship between electricity and magnetism. That is, electricity can be generated with the help of magnetism. Let's go through Faraday's first law. Faraday's first law states that whenever there is a change in magnetic flux linking with a coil or conductor, an EMF is induced in it. This is Faraday's first law. That is, Faraday's first law states that whenever there is a change in magnetic flux linking with a coil, an EMF is induced in it. That is, whenever there is a change in magnetic flux linking with a coil, an electromotive force is induced in it. That is, it relates to the basis of generation of electromotive force. That is, if you have a magnetic field and we have a coil, if we vary the magnetic field or if we move the coil across the magnetic field, an EMF is induced in it. Faraday's first law provides the basis for generation of electricity from magnetism. That is, whenever a change in magnetic flux linking with a coil, an EMF is induced in it. And if we provide a closed circuit or a closed loop for the coil, an electric current will flow through it, and this electric current can be used for doing some useful work. That is, this electricity generation principle is based on Faraday's first law. It provides the basis for electromagnetic induction. And if the conductor, let's read, if the conductor forms a closed loop, if the conductor or coil forms a closed loop, electric current will flow through it. So this phenomena of generation of electricity is termed as electromagnetic induction. Here, electricity is produced from magnetism and there is no physical connection between the magnetic field and the conductor. Change in magnetic flux linking with a coil leads to generation of EMF. This change in magnetic flux can be achieved in two ways. We can either using a moving conductor, or you can either move a conductor in a constant magnetic field, or we can use a varying magnetic field, or we can use a varying or changing magnetic field to link with a stationary conductor. Therefore, EMF can be generated in two ways. Either the magnetic field is varying or the conductor is moving. In both ways it happens is there is a varying magnetic flux linking with the coil and EMF is induced in it. And based on that, the induced EMF is classified into statically induced EMF and dynamically induced EMF that we can learn later. Let's go through second law of electromagnetic induction. Faraday's second law of electromagnetic induction. Faraday's first law gives the cause or the action which leads to generation of electricity, and Faraday's second law gives the magnitude of induced EMF. This law states that the magnitude of induced EMF, the magnitude of EMF induced is directly proportional to the rate of change of magnetic flux linking with the coil. This is Faraday's second law of electromagnetic induction. This law gives the magnitude of induced EMF, and it states that the magnitude of induced EMF is directly proportional to the rate of change of magnetic flux linking with the coil. That is, greater the rate of change of magnetic flux linking with the coil, greater the variation of magnetic field, greater will be the value of EMF induced in the coil. That is, EMF induced is directly proportional to the rate of change of magnetic flux or flux, rate of change of flux linking with the coil. We can represent it as induced EMF E is directly proportional to rate of change of magnetic flux. That is, let N phi 1 be the N phi 2 be the final flux and linkage, and N phi 1 be the initial flux linkage. Then the rate of change of flux linkage can be given by N phi 2 minus N phi 1 by T. That is, if according to second law, E is directly proportional to N phi 2 minus N phi 1 by T, where N is the number of turns, of the coil, phi 1 is the initial flux, phi 2 is the final flux, and T is the time taken for change of flux from phi 1 to phi 2. So E is proportional to N phi 2 minus N phi 1 by T. This is Faraday's second law, and it can be represented as E is equal to constant of proportionality K into N phi 2 minus N phi 1 divided by T. And in differential form, this equation can be represented as E is equal to N into d phi by dt. E is equal to N into d phi by dt, where K is equal to 1. Constant of proportionality K is equal to 1. Therefore, we can represent induced EMF is equal to N into d phi by dt. This is Faraday's second law of electromagnetic induction. These are very two important laws in electrical engineering. We have to carefully understand these both laws. This is provide the basic for the working of electrical generators, motors as well as transformers. Therefore, first law states that whenever there is a change in magnetic flux linking with the coil, an EMF is induced in it, and second law gives the magnitude of this induced EMF. That is, this magnitude of induced EMF is directly proportional to rate of change of flux linking with the coil. That is, it is directly proportional to the rate of magnetic flux change that is linking with the coil. That is, E is equal to N into d phi by dt. That's all about Faraday's law and electromagnetic induction. Thank you.